Hello friends, welcome to this channel. In this session, we are going to discuss about S3 default encryption. So without any further ado, let's get started the session. So if you wanted to push an object into an S3 bucket and wanted to make sure that that object was encrypted, then you would force encryption using a bucket policy, and the bucket policy sees that if the encryption headers are not specified in the API call made it to Amazon S3, then you deny the request, right? And therefore the effect of that every object that is put it into your S3 buckets has to be encrypted. Now that's one way of doing it, but there is another way, and it is to use the default encryption option in Amazon S3. So the idea is that if you upload an unencrypted object into Amazon S3, it will be encrypted using the default encryption options. But if you already uploaded encrypted, then it will not be re-encrypted. Now, something should notice that bucket policies will be evaluated before default encryption. So, for example, if you wanted to force an encryption mechanism of SSE S3, for example, you would need to use the bucket policy. But if your requirement is just to make sure that every single object in your bucket is encrypted, for this you could use default encryption. So now let's see practically. So let's create a new bucket over here. Here in bucket name, let's say S3 default encryption demo 2022, and then simply we are going to create this bucket. So now under the bucket itself, as you can see for properties, you have a look at default encryption, and here we can automatically encrypt a new object stored in this bucket. So we will edit and enable it, and we will select it, the type of encryption scheme we want. Do you want do you want Amazon SSE S3, or do you want SSE KMS? And then you specify your key. So we will use SSE S3 for this example, and it will save my changes. And now, as you can expect, if I add a file over here, for example, let's say this castle.jpg or jpg, and then as you can see, I do not specify any encryption mechanism here. So simply upload and click on close here. Now if I go to my object and have a look at the encryption field in here, then we can see that yes, server side encryption setting is enabled for this object, and it was using the server side encryption Amazon SSE S3. Okay, now if we try to upload another object now, so now let's upload a mountain.jpg, but this time in term of properties I am going to specify an encryption key, and here we can use either the default encryption bucket setting or we can override them. So if we override them and for example use this KMS using the managed key AWS S3 KMS key. So now simply click on upload, and now we have a look at the file itself. So let's click on it and scroll down to the encryption block. Here we go. As you can see, now even though default encryption is enabled, this file was encrypted using SSE KMS and the KMS key that we specified. So remember, the default encryption is not applying the same encryption to all files. It is just making sure that if you upload the object in unencrypted way, then you will automatically be encrypted using the default encryption mechanism. In this session, we are going to discuss about Amazon S3 access logs. So without any further ado, let's get started the session. S3 access log. So say that for audit purposes, you want to log all the accesses into your S3 buckets. So that means that any request that is done to Amazon S3 from any account, authorized or denied, you want it to be logged into another S3 bucket. So you can analyze it later. So you can analyze it, for example, using data analyzing tool or something we will see in the further session called Amazon Athena. So here's the idea with the diagram. We will request into a bucket and that bucket has been enabled for login into another bucket or login bucket. And so all the requests, once we have enabled the S3 access logs, will log all the requests into the login bucket. So it's very easy, very simple, and the log format is defined here. So if you are interested about how we can read this log, just click on this link. And okay, so now something you should know about this login buckets, that is very pretty natural, but you need to know about it once. So do never ever set your login bucket to be the bucket you are monitoring. Otherwise, if you set the login bucket and the monitoring bucket to be exactly the same, then it will create a login loop and your bucket will grow in size exponentially. So let's see here. Let's say we have a bucket. It happens to be our application bucket and also the bucket that is going to receive all the logs. And so therefore, whenever a user puts an object, the bucket is going to log inside of itself, create a login loop, and they will create a new object. They will be logged in a new object that will be logged. So it creates an infinite logging loop. So that's that's why your bucket will grow in size exponentially. So my advice to you is, do not try this in your personal account. This will end up in huge AWS bill for doing this little mistake. So always separate your application bucket and your login bucket. So now let's go in the hands-on, so you will you will see how this will work. So as you can see, this is my AWS S3 console. Now let's demonstrate S3 access login. So let's create a new bucket. I will call it demo S3 access logs 2022, and then I will leave all this setting on and click on create bucket. Okay, so this is creating my bucket, and this bucket is going to be used for access login for my other bucket, right? So now let's take my demo S3 bucket 2022 and I'm going to turn on server access login. So for doing so, I am going to go into properties and I will scroll down a little bit over here and I will find the server access login in here. Next, I will click on edit and then simply enable server access login. Next, I need to specify a target bucket. So I can just browse Amazon S3 and select the bucket that we just needed. Choose the path and we can do, for example, slash logs slash. If you want to have all the server access logs to go under the S3 dash logs folder, it's up to you, it's optional, but add a trailing slash at the end. Now save the changes and we are good to go. So now it is enabled, and the idea is that if I go and, for example, list my versions here, if I go and take this castle.jpg file and open it, and this is going to generate some traffic onto my bucket. Okay, and this is going to be logged onto my other bucket called demo s3 access log 2022. Now this can take an hour or 2 hours to appear, so I am going to wait a little bit for it to be written. But one question you may have is, by turning on the server access login, how is this bucket getting the right to my logging bucket? And so it says here, by enabling server access logging, the S3 console will automatically update your bucket access control list, that is ACL, to include access to the S3 log delivery group. So let's check this out. Let's go to permission of my demo S3 access log bucket. And under the permission, if I scroll down and go to access control list ACL, yes, the S3 log delivery group has the right to write my objects onto my S3 bucket. So this is something that has been added automatically by Amazon S3 when I did enable server access login. Okay, so now the only thing I have to do is wait. So I will pause the video and hopefully within an hour or two I should be able to see some objects being populated in here. So I'll see you very soon. Okay, so I am in my access log bucket. I have waited an hour, so hopefully now I started seeing an s3 log folder here, so that has been created. So perfect. And within that folder it's contain our access logs of what has been done on my s3 bucket. So I can take any of this file. I can take this one for example, and I can download it. So as you can see, it is a text file. So I'm going to open it with my any text editor to see what it's inside. And so I just opened this file and this is the text file, as you can see. So this is one line. So this contains 1 bit of information in this specific file. And this tells me about the request ID, the bucket it was made on, the time and date of this bucket request, the IP it's coming from, and that is fact it was a get. So it was a successfully get on a bucket. So it was probably like a request done at the top of the bucket. So this type of access logs can be analyzed at scale using something like Athena that we will see in the further sessions. And so on their own they are not very helpful, but if there are any problem, if there is any authorization issue or attack whatever, Athena analyze these files and getting down to the bottom of it will allow you to get more insight into what is happening, right? In this session we are going to discuss about Amazon S3 replication. So without any delay, let's start the session. Amazon S3 replication, that is CRR and SRR, for cross region replication and same region replication. At its core of the idea, we have an S3 bucket, for example, in one region, and we want to replicate it asynchronously into another region, into another bucket. So to do so, we first must enable versioning in the source and destination buckets, and then we can set up two different things: cross region replication CRR if the two buckets are in the different regions, or same region replication SRR if the two buckets are in the same regions. Note that the buckets can be in different accounts, so it is very possible for you to save a copy of your data into another account using S3 replication. The copying happens asynchronously, but it is very quick. And for the copying to happen, you need to create an IAM role. We will see in the hands-on, and that IAM role will have the permission from the first S3 bucket to copy through the second S3 buckets. So the use the use cases for cross region replication is for compliance or lower latency access of your data into another region. So, or to do cross account replication and SRR, so same reason replication, the use cases could be log aggregation. So you have different logging bucket and you wanna centralize them into one bucket or leave replication. For example, between a production and your test account. And so here is a fine print about S3 replication. After you activate S3 replication, only the new object are replicated, so it is not retroactive. It will not copy your existing state of your S3 buckets. And for delete operation, there is an option setting to tell tell you whether or not you want to replicate your delete marker from the source to the target. Or if you specify the deletion of a specific version ID, then it is not going to be replicated to avoid malicious deletes. And finally, there is no chaining of replication. That means that if bucket 1 has replication to bucket 2, which has replication into bucket 3, then any objects created in bucket 1 will be in bucket 2 but will not be replicated to bucket 3. So we cannot chain your replication. So that's a fine print for S3 replication. Now let's go to hands-on to see how that works. Okay, so let's have a play with S3 replication. Here is my S3 console. So I'm going to create a first bucket. So I'll say demo easy AWS origin 2022 and in US East 1. And here I am going to enable bucket versioning because for replication you need to enable bucket versioning on both the source and the target bucket. So we will create those buckets, and so this is my first bucket created, demo easy AWS origin 2022, and it was in US East 1. But I am also going to create a second bucket called demo easy AWS replica 2022, and this time I am going to choose something like in the or EU West 1, for example, to replicate my data from US into the EU. Maybe it is a disaster recovery strategy for yours. Okay, so I'll scroll down. I will enable bucket versioning again and simply click on create bucket. Okay, so now both my buckets have been created. So my origin buckets and my replica buckets, and now let's open them in new tabs. What I want to do is start uploading one object into my demo easy AWS origin 2022. So I will upload here the castle.jpg file and simply upload it. Here we go. And so right now, as we can see, it is in my demo origin bucket, but obviously we have not configured anything, so it is not yet in my demo replica bucket. Okay, so for this now I want to set up replication. So you need to go into management, and here under the management there is replication rules. So we can create a replication rule here, and I will just call it as demo rule, and the rule is enabled. And what we do is we can limit this rule to a specific scope within the bucket, so a subset of objects, or we can specify that this rule applies to all objects in the buckets. So it is up to you, but Right now we want to keep it simple, so let's apply it to all objects and the buckets. Next, we need to a destination, so it could be bucket in this account or in another account. So let's choose a bucket in this account. Now we will browse S3, the demo replica bucket. So we'll choose this, and as we can see, the destination region is now EU West 1, and so this is cross region replication. But if the destination region was the same, it would be a same region replication. For your replication setting, okay, so finally you need an IAM role here to perform this action. And so we can just ask Amazon S3 to create this role for us, which is very nice. Now, in term of advanced setting, I'm just not going to check anything. We just want to demonstrate the capacity right now. So, and here the delete marker replication right now is disabled. So delete markers are not replicated, but if you enable it, delete markers would be replicated, and it will demonstrate this in a second. But right now I will leave this as delete marker replication off. Okay, so I will save this, and now my replication rule has been created and currently configured. So what you would expect is that if we go into the origin bucket, we see one object castle.jpg. And if we go into the replica bucket here and refresh it, well, we'll still see zero object here. So it turns out that as soon as you enable replication, it will not replicate old object for you, previous objects. So it will only replicate newer objects. So how do we fix this? Well, we can upload the castle JPEG file again. So let's upload castle.jpg and simply click on upload. Now this has uploaded the castle.jpg file here again in my bucket. So if I list version now of 2, and you can see we have a new version of this file. Now if I go to my replica bucket and here refresh it, within a few seconds I should be seeing this object popping up. And here we go, my object has now appeared, and we can look at the fact that the version ID of this castle.jpg is the exact same as the version ID I have on my origin bucket, as you can see. So the object is replicated including the object version ID. And if I upload, for example, here mountain.jpg, it's obvious that if it is also going to be replicated. So hopefully this makes sense. Now let's look about deletes. So if I take my castle.jpg here and delete it, so I'm going to create a delete marker and press and click on delete. So this delete marker that is created is not going to be replicated. So let's prove it to our save. So right now we only have the mountain.jpg in here in the origin bucket, and if I refresh here, I have castle.jpg. So the delete marker did not get passed on to the our replica bucket, and we started from before. This was just a setting in the replication rule. So if we specify, we could also tell Amazon S3 to replicate this delete marker, but this is something you have to opt in by default. And finally, if I list my versions and say I wanted to delete a very specific version of my file, so let's say delete all these files right here, and I will permanently delete this because I am deleting specific version IDs in my buckets. So this is something good to know, and definitely a behavior you should be aware of at your exam. Okay, and that's it for replication rules. I would say you can set up different replication rule in your buckets based on different prefix and filters, and you can edit the rule if you wanted to. For example, if you wanted to delete the marker replication as well to enable it, but for now we will not do it. We show the basic of replication and that should be enough for the exam. S3 storage classes. And into the exam, you need to know about all storage classes and understand which one is most adapted to which use case, right? So this lecture is going to be quite long and I want to describe to you all the different storage classes. So let's get start the session. The first one is the one we have been using so far, which is Amazon S3 standard, which is for general purpose, but there are some more optimized one depending on your workload. The first one is S3 infrequent access or IA, also called as S3 IA. So this one is when your file are gonna be infinitely accessed, and we will have a deep dive by the way on all of them, right? There is gonna be S3 one zone IA when we can recreate data. There is going to be S3 intelligent tiering, which is going to move data between your storage classes intelligently. And now Amazon Glacier for archive and Amazon Glacier deep archive. For the archiving, you don't need right away. Finally, there's one last class called Amazon S3 Reduced Redundancy Storage, which is deprecated and therefore I will not be describing it in detail through this session. Okay, so S3 standard general purpose. We have very high durability is called 11 9, so 99.9 times 9 of objects across multiple AZ. So if you store 10 million objects with Amazon S3 general purpose, you can on average expect to incur a loss of a single object, one every 10,000 years. Bottom line is you should not lose any objects on S3 standard. There is a 99.99 availability percentage over a given year. And all these numbers, by the way, you don't have to remember. This is just indicative to give you some knowledge. You don't need to remember exactly the number going into the exam, just since you understand the general idea about a storage classes. And it can sustain two concurrent facility failure. So it's really resilient to AZ disaster. The use cases for general purpose is going to be big data analytics, mobile and gaming application, content distribution. This is basically anything we have been using so far. Now we have S3 standard infrequent access or IA. And this is suitable for data as the name indicates, that is less frequently accessed but requires a rapid access when needed. So we get the same durability across multiple AZ, but we have 1/9 less availability and it is lower cost compared to Amazon S3 standard. The idea is that if you access your object less, you will not need to pay as much. It can sustain two concurrent facility failure, and the use cases for this is going to be a data store for disaster recovery, backups, or any files that you expect to access way less frequently. Now we have S3 one zone IA or infrequent access, and this is the same as IA, but now the data is stored in a single availability zone. Before it was stored in multiple availability zone, which will be let us into make sure the data was still available in case an AZ went down. So we have the same durability within the single AZ, but if that AZ is somewhat destroyed, so imagine an explosion or something like this, then you would lose your data and you have less availability, 99.5% availability, and you have still the low latency and high throughput performance you would expect from S3. It supports SSL for all the encryption and is going to be lower cost compared to infrequent access by about 20%. So now the use case for one zone IA is going to be to store secondary backup copies of on-premise data or storing any type of data we can recreate. So what type of data can we recreate? Well, for example, we can recreate thumbnails for an image. So we can store the image on S3 general purpose and we can store the thumbnail on S3 one zone infrequent access. And if we need to recreate that thumbnail over time, we can easily do that from the main image. Then we have S3 intelligent tiering and it has the same low latency and high throughput as S3 standard, but there is a small monthly monitoring fees and auto tiering fees. And what this will do is that it will automatically move objects between the access tier based on the access patterns. So it will move objects between S3 general purpose, S3 IA, and so it will choose for you if your object is less frequently accessed or not. And here you are going to pay a fee for S3 to do that little monitoring. So the durability is the same and it is designed for 99.9 availability and it can resist an entire event that impact an availability zone. So it's available. Okay, so that's for general purpose S3 storage tiers. And then we have Amazon Glacier. So Glacier is going to be more around archive Glacier's cold. So think cold archive. It's a low cost object storage, mean really for archiving and backups. And the data needs to be retained for very long time. So we are talking about tens of years to retain the data in Glacier. It's a big alternative to on-premise magnetic type storage where you would store data on magnetic tapes and put these tapes away. And so if you wanted to retrieve the data from these tapes, you would have to find the tape manually, put it somewhere and then restore the data from it. So we have still the 11 lines of durability, so we don't lose object and the cost per storage is really low. $0.004 per gigabyte plus a retrieval cost. And well, see that cost in a second. So each item in Glacier is not called an object, it's called an archive. And each archive can be a file up to 40 terabyte. And archives are stored not in bucket, they are stored in vaults. Okay. So we have two tiers within Amazon Glacier we need to know about. The first one is Amazon Glacier, the basic ones, and we have three retrieval option and they are very important to understand. Expedited, which is 1 to 5 minutes, so you request your file and between 1 to 5 minutes you will get it back. Standard, which is 3 to 5 hours, so you wait a much longer time. And bulk, when you require multiple files retrieval at the same time, which takes between 5 to 12 hours to give you back your file. So as you can see here, Amazon Glacier is really to retrieve files and not have some kind of urgency around it. If you are very in a rush, you can go and use expedited, but it's going to be a lot more expensive than using standard or bulk. And the minimum storage duration for Glacier is going to be 19 days. So again, files that are going to be in Glacier are therefore the longer term, and we have an even deeper storage tier for Glacier called Deep Archive. And this is for super long term storage and it's going to be even cheaper. But this time the retrieval option are standard 12 hours, so you cannot retrieve a file in less than 12 hours. And bulk, if you have multiple files and you can wait up to 48 hours, it's gonna be even cheaper. So deep archive we will see is going to be for files that you really don't need to retrieve urgently even if it's archived. And minimum storage duration of for deep archive is going to be 180 days. Now you have to remember these numbers at a high level because going into the exam there will be question asking you to understand which point to pick between glacier and glacier deep archive. And for example, if the storage file is going to be less than 180 days, then you have to use glacier. If you need to retrieve the file very quickly between 3 to 5 hours, is going to be glacier. But if it's going to be file to be retrieved in 72 hours and is going to stay for 1 year in your vault in glacier, then maybe deep archive is going to be provide you the best cost saving. So let's compare everything that we have seen. So we have seen S3 standard, intelligent peering, standard IA, one zone IA, glacier, and glacier deep archive. So for durability, there is all 11 nines. So that means you don't lose any object for availability. While the ones that we can look at is S3IA because it's a infrequently accessed, we have a little bit less availability. And if it's one zone IA, then it's going to be even less availability because we only have one availabilities on them. So that makes sense. For the SLA, this is what Amazon would guarantee you to reimburse you, and it's not something you need to know about, but I will just put it in this chart in case you need it in real life. So now the number AZ your data stored onto is going to be 3 everywhere except in one zone IA because as the name indicates it's only for one zone. So you are going to have one, then there is a minimum capacity to charge per object. So when you have the normal S3 or intelligent tiering, you are fine. But when you are using IA, you need to have a large object large rather large than 128 kilobyte, and for glacier it's 40 kilobytes. The minimum storage duration is going to be 30 days for standard IA, 30 days for one zone IA, and for glacier is 90 days. For Glacier Deep Archive, it's 180 days. And then finally, is there a retrieve fees? For the first two, no, there is not, but it's when you have standard IA because it's infrequently accessed, then you are going to be charged a fees anytime you retrieve the data. And then for Glacier Deep Archive, again, there is going to be a fees based on the number of gigabyte you received and the speed you want to receive it. So you don't need to know all the numbers in it, but the number should make sense from what the storage tier really means to you. Okay. And for those who like numbers, here just the chart that I have. You can look up on your own time, but what it shows is that the cost of SD standard is 0.023, which is high. And if we go all the way to the right to glacier, we have deep archive. So we have 0.00099 per gigabyte per month, which is a lot cheaper. And so if you want to if you want the data fast enough for intelligent tiering is gonna be between 0.23 and 0.0125. Standard IA is going to be that number and one zone IA is gonna be even cheaper and so on. And it shows also the retrieval cost. So if we want to expedite retrieval from glacier, it's going to cost us $10 per thousand requests. Whereas if we use standard or bulk, it's going to cost us lot less. Same for Glacier Deep Archive. Okay. And finally, for S3 intelligent tiering, there is a cost to monitor object because it's gonna be able to move them between S3 standard and S3 standard IA on demand. And so the cost is quite small, but it's 0.0025 per thousand objects monitored per month. Okay, so that's it now. Now let's go into hands-on to see how we can use these tiers. So as you can see, this is my S3 console. Now let's have a look at storage classes. So I'm going to create a bucket here. let's say demo 2022 storage classes, and I will scroll all the way down and simply create bucket. So this is a whole new bucket here, and I am going to upload my first object in here. So I am going to upload an object named castle.jpg. Okay, so if we expand the properties option, we can have a look at the storage class option. So here we get access to all the storage classes we have learned. So we have standard, intelligent tiering, standard IA, one zone IA, and so on. So we have all the option here, and there is a summary of what each storage class means. For example, how many AZ are available, the minimum storage duration, the minimum billable object size, some fees in terms of auto tiering, and retrieval fees. You can also click on this learn more and Amazon S3 pricing button and links if you want to to learn more and get access to the documentation, obviously, as well as the pricing documentation in case you have any doubt. So but for example, let's choose to upload this file in standard IA, which is infrequently accessed, and let's see if that works. So we will click on upload, and here we go. Our file has been uploaded, so I can happily upload another file now. For example, I can upload my mountain.jpg, and if I choose to upload my mountain.jpg in the glacier, then it will not allow me to see this file immediately unless I retrieve it. So let's have a look. So I have got to restore it first. So I have my mountain.jpg, and as you can see, the storage class is glacier. So whereas castle jpeg, the storage class is standard IA. So if I click on mountain.jpg, it says this object is stored in the glacier storage class. In order to access it, you must first restore it. So that makes sense. Whereas if I go to the castle.jpg, I am easily able to open and view it. For this mountain.jpg, I cannot open it. I first need to initiate a restore, which is going to take some days to restore. It could take between 5 to 12 hours if I do it with bulk retrieval. Standard is between 3 and 5 hours, and expedite between 1 and 5 minutes. And it's going to be a lot more expensive, right? And how many days do I want to want the restored copy to be available in days? So it's going to take a lot of time for me to show you this, but you get the idea because it is in glacier, then it's going to take some time to restore it, right? And finally, it is possible to you to edit the storage class of an object. So this object right here is in standard IA, as you can see, but I can edit it, and I can change the storage class to standard or one zone IA, or we just run on intelligent steering. So for example, let's move this to intelligent tiering. Save changes, and here we go. The storage class of that object has been changed. Lifecycle rules of Amazon S3. So let's get started the session. So you can transition objects between storage classes as we have seen in the previous hands-on on storage classes, right? So if you have not seen that video yet, please go and watch that first. So we can transition object, but we can do it in what way? Well, there is a giant graph on the AWS website that describes how to do it. So it's pretty complicated, but as you can see from standard IA, you can go to intelligent tiering, one zone IA, and then glacier, then deep archive. And it just shows the possible transition. And as you can see from glacier, you cannot go back to standard IA. You have to restore the objects, and then copy that restored copy into IA if you wanted it to. So for infrequently accessed objects, move them to standard IA. For archive objects that we do not need in real life, the general rules is to move them to Glacier or Deep Archive. And so moving all these objects around all these classes can be done manually. But it can also be done automatically using something called a lifecycle configuration. And configuring those is something you are expected to know going into the exam. So lifecycle rules, what are they? You can define transition actions which are helpful when you want to transition your objects from one storage class to another. For example, you are saying move objects to standard IA class 16 days after creation and then move to Glacier for archiving 6 months later. So fairly easy and fairly natural. Expiration actions, which is to delete an object after some times. So for example, you access log files, maybe you don't need them after another year. So after a year, you will say, hey, all my files are over a year old, please delete them, please expire them. And it could also be used to delete old versions of a file. So if you have versioning enabled and you keep on overriding a file, and you will not need the previous version after maybe 60 days, then you can configure an expiration action to expire object old version of a file after 60 days. It can also be used to clean up and complete multi-part uploads in case some parts are hanging around for 30 years and they will never be completed. Then you would set up an expire action to remove these parts. And rules can be applied for a specific prefix. So if you have all your mp3 files within the mp3 prefix, then you can set a lifecycle rule just for that specific prefix. So you can have many lifecycle rules based on many prefix on your buckets. That makes sense, right? And you can also have rules created for a certain object tags. So if you want to have a rule that applies just to the object data tag like department, finance, then you can do so. So the exam will ask you some scenario questions, and here is one, and you need to think about it with me. So your application EC2 creates image thumbnails after profile photos are uploaded to Amazon S3, and these thumbnails can be easily recreated and will only need to be kept for 45 days. The source images should be able to be immediately retrieved for these 45 days, and afterward the user can wait up to 6 hours. How would you design this solution? So I will let you think for a second. Please pause the video and then we'll get to the solution. So the S3 source image can be on the standard class, and you can set up a lifecycle configuration to transition them to Glacier after 45 days. Why? Because they need to be archived afterward, and we can wait up to like 6 hours to retrieve them. And then for the thumbnails, they can be one zone IA. Why? Because we can recreate them, okay? And we can also set up a lifecycle configuration to expire them or delete them after 45 days. So that makes sense, right? We don't need the thumbnail after 45 days, so let's delete them, and let's move the source image to Glacier, and the thumbnail can be on one zone IA because it's going to be cheaper, and in case we lose an entire AZ in AWS, we can easily from the source image recreate all the thumbnails. So this is going to be providing you the most cost efficient rules for your S3 buckets. Now, in second scenario, there is a role in your company that states that you should be able to recover your deleted S3 objects immediately for 15 days. Although this happens rarely, after this time and up to 1 year, deleted objects should be recoverable within 48 hours. So, how would you design this to make it cost efficient? Okay, let's do it now. So you need to enable S3 versioning, right? Because we want to delete these files, but we want to be able to recover them. And so with S3 versioning, we are going to have object versions, and the delete objects are going to be hidden by delete marker, and they can be easily recovered. But we are going to have a known current versions, basically the objects version from before. And so this non-current versions, we want to transition them into S3IA, because it's very unlikely that these old objects versions are going to be accessed. But if it do are accessed, then you need to make sure to recover them immediately. And then afterward, after this 15 days of like glacier period to recover these non-current versions, you can transition them into deep archive, such as for 365 days it can be archived and then will be recoverable within 48 hours. Why don't we use just glacier? Well, because glacier will cost us little bit more money, because we have a timeline of 48 hours, and so we can use all the tiers all the way up to deep archive to reach your file and get even more saving, right? So this is the kind of exam question you would get, and it's really important for you to understand exactly what the question is asking and what storage class is corresponding the best to it, and what lifecycle rules can also correspond to base to it. So now let's go into the hands-on just to set up lifecycle rules. Okay, so now let's have a look at lifecycle rules. So this is my bucket that we created in the last session, and now for this I'm gonna go into management, and I can define here lifecycle rule. So let me create one. I will call this one, let's say, demo rule, and we can either play it to a specific scope within our bucket or all the objects. So I will apply to all the objects just for simplicity's sake in this video. So we have 5 different kind of lifecycle rule action. We can transition current version of object between storage classes or previous classes. So what do we mean by current and previous? Well, for current, we mean the object that is the most recent if we have enabled versioning, and for previous we mean all the other version of an object if we have enabled versioning. Then we can expire current version of objects, permanently delete previous version of objects, and finally delete expired, delete markers or incomplete multi-part uploads. So lots of different option here, but let's just do this one. So we are going to transition current version of objects between storage classes, and we can say we can transition object into the standard IA storage class after, let's say, 30 days. Then we can move it to intelligent tiering after 70 days, and then move it into maybe glacier after 180 days, and then glacier deep archive after, let's say, 365 days. Okay, and here is a small warning. If you transition your small objects into glacier or glacier deep archive, this will increase cost. So obviously if you do transition objects there, make sure they are big enough. Okay, great. So next, I can also expire current versions of objects. Now here, after an object is created, maybe after 700 days, then please delete it. And here we could also add a previous version transition just for fun, and we can say it's move it into Glacier after let's say 60 days. Because if it's approved version, maybe we don't want to access it, we don't plan on accessing that. Okay, so I acknowledge this, and so we can look at the timeline summary. And so for current version action, day 0 the objects are uploaded, day 30 they are transitioned automatically into standard IA, day 70 into intelligent tiering, day 180 to Glacier, and finally 365 Glacier deep archiving. Day 700 they will expire, and then for previous version action this year they become non-current, and day 60 they are transitioned to Glacier. Just a simple fun lifecycle rule to set up, but this shows you the whole power of lifecycle rules, right? You can set up multiple ones per bucket on different filters with different rules, and this allow you to really optimize your cost in AWS for Amazon S3. Amazon S3 event notification. So without any further ado, let's get started the session. Okay, Amazon S3 event notifications. So some events happen in your S3 bucket. For example, this could be a new object created, an object removed, an object that has been restored, or there is some S3 replication happening, and so you want me to able to react to all these events. You can create rules, and for these rules you can also filter by object names. For example, you want to react only to the JPEG file, so start.jpg, and so you can create event notification rules, and these rules allow you to trigger some sort of innovation inside of your AWS account. So use case for it, a very classic one, will be to generate thumbnails of images uploaded to Amazon S3. So what are the possible targets for S3 event notifications? Well, so you have three. You have SNS, which is a simple notification service to send notifications and emails. We have SQS for a simple queue service to add messages into a queue. And finally, Lambda function to generate some custom code. Now, we will see all these service SNS, SQS and Lambda in detail in this series, but for now just remember that you have these three targets for Amazon S3 for event notification, and that will make a lot of sense by the end of this course. You can create as many S3 events as desired, and most of the time they will be delivered in seconds, but sometimes it can take a minute or longer. And there is a small caveat, which is that if you want you to make sure every single event notification is delivered, you need to enable versioning on your bucket. So this is what these two very long lines of text are saying, and this comes from the documentation. So let's go ahead in the console to see how we can set up a very simple S3 event notification. Okay, so this is my AWS S3 console, as you can see. Now let's demonstrate S3 bucket notifications. For this, I'm going to create a new bucket, and then I'll call it as demo 2022 S3 bucket notifications. Okay, I'll create it in US East 1 Virginia, and scroll all the way down and simply create this buckets. So next I will click and open this bucket, and I want to go into properties, and I want to change my event notifications. So as you can see, where we have multiple ones, so I want to create an event notification, and I will call it as demo event, and for the prefix it's optional, so I will set none this way, applies to all the objects within my buckets, as well as suffix is optional and so on. Now, what is this event happening applies to? So I want to have this event triggered anytime an object is created. So that is object created, put, post, copy and multi-part upload completed. But you could also, if you want to have other calendar events such as deletes event, restore events and so on. So for now, I'm just going to select all objects create event for S3 object create to start. Next, we need to choose a destination. And so the destination could be a Lambda function, an SNS topic or SQS queue. Now, we have not seen those yet, but we will be using an SQS queue and we will be creating a queue ourselves. So let's go ahead and create a queue. So let's go to SQS and create a queue for that matter. So we will create a queue, and this queue I'm going to call it as standard and let's say demo S3 notifications. We are good to go, and I'll scroll all the way down and click on create queue. So my queue is now created, and what I need to do is to set up an access policy. And the access policy I need to set up is an access policy that will allow my S3 bucket to write to my Amazon SQS queue. So no need to worry about what SQS is right now, but just follow with me. So let me refresh this page just to make sure that I get my queue picked up. So we have to say demo event again one more time for create objects and scroll down SQS queue and find my demo S3 notifications. So now if I save the changes right now, is going to give me an error because I am unable to write to my SQS queue. So let's change the access policy to allow people to write to my SQS queue. So I will change it, and the access policy itself, I can use a policy generator to define an SQS queue policy. So and I will make it very permissive right now. So I'll allow anyone to do a send message into my SQS queue, and I need to find the ARN of my SQS queue, and the ARN is, you can see right here. So here we go. I'll paste it in the ARN, and a statement generate this policy, and this should allow anyone including my S3 buckets to write to my SQS queue. Now this is way too permissive but good enough for this demo. So I paste it and then I will save this. So now my access policy should allow my S3 buckets to write your SQS. So let's save the change one more time, and this time the operation successfully completes. Finally, let's go and upload an object to see if that triggers an event. So we will add a file and we will add castle.jpg and upload this file and see what happens. Okay, so this file has been successfully uploaded. This is good. Now let's go into my Amazon SQS, and under the Amazon SQS you can go to send and receive messages on the top right corner, and under receive messages this is going to receive this message. So here they are. So the first message is that, and if we look at the body, we can see that this was a test event from Amazon S3. This is when Amazon S3 was testing the connectivity between S3 bucket and the SQS queue. So we can safely disregard these events. And the second event, if you look at the body, now this contains the actual notification that was sent by Amazon S3 into SQS queue. So we can see the source is AWS S3. It was in the US East 1 region and the event name was object create puts. We can see who did it and some IP here and a lot of information about that event in particular. So this demonstrates that yes, our S3 bucket is able to send notification into Amazon SQS and the completed demo. So guys, that's it for this session. I hope you like it and I will see you in the next lecture. If you have any doubt or any question, feel free to ask in the comment section below. I will answer you as soon as I can. So thank you for watching. Bye and have a nice day.